Okay, this is a video that continues that I am required to put, I'm not really required, I should say it slightly differently, that I'm going to put into this a modeling class. Okay, and I've already gone through a couple and I haven't put them on the page yet. And here's what happened. I made a course and I promised to be so structured it was incredible. I gotta say, 8 hours of a modeling class is absolutely torture on Zoom. It's totally fine if we're in person. And I'm going to eventually make some classes for you. I'm really going to do that instead of wasting my time with these other people who just give you crap all the time. And I'm going to keep it very structured, and that's what I'm trying to do. So we went through, of course, I already told you about these history of modeling and the religious stuff. And now I'm going to move in, and I'm right here. I need to put the file associated with. If you want to just start with a blank sheet, which I don't want to do anymore because we waste too much time on typing titles. Of course, I put the counting on the fingers and my horrible problems with timing. And this time, in this session, I'm going to work through. It took me this long just to get to tell you what I'm going to do here, which is to work through the operating components of or the operating parts of a renewable model. And the reason I am doing this is because these crazy people who I worked for said you're not allowed to record a session. You're not allowed to record the the course. Okay, so I said, and they didn't even show up for the video, and I said, okay, look, people, this is ridiculous. If you can't remember how to do little things here, and you're just starting modeling, how could you remember any of this stuff? You're supposed to forget all my babbling, but there might be some formulas you kind of want to remember, and how to do norm inverse, and how to make a P90, and how to do a mean squared error from the standard deviations, and how to set up the generation and the degradation in a sheet, all those kind of things. Okay, so that's what we're going to do this time, and then if I get time, I think I'll probably be too tired and too frustrated. What a shit day I had today with messing around with crap I thought I resolved on this monster model, and I can't. It's only 45 megabytes after you put the whatever, save it as a binary crap. Ugh. And you don't need to hear about my moaning, and I hope I'm not sounding like some kind of victim. I'm not. Maybe a rebel. I want to be a rebel, not a victim. Please, if I'm doing this for the people who took the class. Now, last time I kind of introduced where we're trying to go. So this model, and it's not here yet. It's not all here yet. When I say we, I'm going to work on the circular reference part of this. Right now, it's got some copy and paste, and it's kind of. I just want to get the ideas here and show you some of the issues in making a model. So right now, I we have in this input C page, we have some scenarios. We have a base case. A base case is going to be the case we use to do some credit and some risk analysis. And then I have a series of 3 debt sizing cases, P50, P99, or P90 rather, P99, debt to capital. I could put a P50 here. You could make as many debt sizing cases as you want. And with these debt sizing cases, we're going to figure out how much debt we have. And you notice I'm going to fix the debt. We're going to copy the debt in. And in this case, I'm going to have a little selection where I take the minimum amount of the debt, or I can take minimum, or I can take and select the amount of debt we want to test. If that didn't mean anything, let me try to explain it with this one. Okay, so right now I'm in the base case. Now let's go to the P90 and size the debt. Okay, and now when we, it doesn't say the P90. When I have this case right now, the first thing you should see is the circular reference isn't solved. So you can press a little button that goes and does the copy and paste. Notice it takes a little time. And we're going to put the UDF, the much better resolution of all this, into this model. I just haven't bothered with it yet because we have a couple things to finish. I want to show you that that's not a difficult process, please. And then if I would do something like increase the standard deviation, which is the issue we'll talk about just in a minute, and then, that means the cash flow goes down because the P90 is below the P50. And if we have a bigger standard deviation, we have a bigger difference between P50 and P90. Now, if you're just beginning, don't worry. You need to explain to your mother what the P50 and the P90 are. And if you go crazy, you have to explain what a P50 and a P90 are for wind, and it all gets crazy. But when I change this, the stupid circular reference has to be pressed again. This is my I have two issues with three issues. The pressing the button, the time it takes, I'm not sure how fast I can make it. And the third is having you do really kind of complicated, multiple different issues and seeing how you can resolve this in a more difficult situation. Okay, so now the debt went to 79. Okay, good. And the next thing is we take this debt that's sized based on the P, in this case the P90, and by pressing this button, it takes that 79 of debt and copies it into this financing page. Now it's a little macro that does that, but I'm going to explain how to do that, and I'm going to explain how to incorporate all these little sensitivity factors in the model. I better get to my case in just a minute. Okay, and then now if we go to the P99 case, what happens is it goes back and resets the thing. So I reset the standard deviation. We have to run the circular reference. And in this case, after we run the circular reference, again, it takes a minute, and I have 86 amount of debt. Now, the P99 case has a lower cash flow, but also a lower DSCR. So you're just sizing the debt just to meet a 1 in 100 year event, if you want to talk about it like that, and a 1 in 100 year event that happens every year, which has an almost 0% probability, blah, blah, blah. And then we have 75 million of debt. And now what I'm going to do is choose this thing called minimum. And then I hope, and then I'm going to run the base case. Oh, shoot, I didn't do something, sorry. And I got to go back to the P99 case, and I've got to copy the debt. Okay, and now if we look at this, which had a lower amount, P99 had a lower amount. So we go back to our summary page, and I hope that that's in here. And then we go back to our base case. And then it's again just illustrating what I'm trying to do. First of all, we have to resolve the circular reference again. I hope you can see getting rid of this button is a big deal. And we're using this amount of debt. We're using the fixed amount of debt, and then we can say, what happens if we have a low degradation in this case? What happens if this wouldn't matter, but I could change a whole bunch of things, the O&M cost, or I should have put a little button on the yield, and that's where we're going. Okay, I didn't kind of explain this. Now to get there, this time, unlike the last case where I just went through counting on my fingers, in this case, we're going to work through some things about capacity and the standard deviations, a little bit on the yields, and work through a couple of things with revenues and expenses, and also prove to you that a financial model and an LCOE should give you exactly the same result. I talked to this man yesterday who wanted to prove these Lazard numbers for the hydrogen, and I guess I'll I gotta finish my book. That's what I care about really, but I'm gonna kind of use a new philosophy since I've made some progress on my book. So I'm going to yes. What I'm going to do is kind of mix them up a little. Okay, whatever. So let's close this file and let's continue with our course. And what I'm really hoping is, and oh, who cares? This feedback shit is driving me nuts. Okay, the person is going to now call everybody. She said, "Oh, you didn't follow the structure carefully enough. I'm trying to show you how structured I am and how structured the models are and how structured this kind of page is." Okay, that was our timeline. And now we're going to go through and build the operations. And this, so you go every time you want to do this, perhaps, oh, maybe that's my problem. I didn't put them in a different color. And some people said, oh, you can't follow this when you're looking on the website enough. Okay. So we're going to go through this one. We've been through the timeline. I have to restate it, I suppose, and pick this file. And so you get this file, and there's a completed one, and we're going to work through, like I said, the generation, and we're also going to good. Generic macros is open as I'm opening the other file. Okay, and we'll start at the bottom. We have some LCOE analysis, and we have 3 different methods of computing the LCOE, which we're going to reconcile against a project finance model. Okay, and I'm going to again introduce this business, which I think is a big deal, that we have the scenarios. You notice I don't have the drop-down box here yet. I'm not going to waste time with doing conditional formatting again. And we have the different input scenarios, and I won't do that much coloring. I won't belabor that. Well, okay, let's do it after this. Just once. Okay, and if we have our P90 scenario, so let's just look what we have. All our dates that I worked on last time. This time we have a capacity of our plant, and we have a standard deviation. And that standard deviation, computing that standard deviation is the big deal. I suppose I was just going to get into it right away, but I'll go through this one. This is a download from PVGIS that I go through over and over again. Go to PVGIS EU. It's the EU. They wonderful. They do this. And get the average. Okay, and when I did the class, I think I put the sum instead of the average, and I got all flustered. You can get the average of, this is a series of years. I'm going too long, so I'm not going. I press Shift Control R, so I'm not going to go and show you. Yes, I will. Oh, damn. Okay, you go to PVGIS. Okay, and whatever. Okay, and it says EU Science Hub to confuse you, and it's a little bit different, but I'm not going to criticize them because they're great. Do I have to do this? Okay, access PVGIS here. Oh, look, they have another thing. Oh, phew, I'm at least there. And then what you can do is, let's find a place we used. I don't. How about here? Let's go here. Let's go here. And this time, let's get the monthly data, and let's go and get a whole bunch of data. And this is just so wonderful that they have all these different kind of databases. And I'm going to get global, global whatever it is, and oh no, this time it only goes to 2016. Maybe if I do this, it'll go longer. And this is extremely important. When you use a different database, you get a different result. And for you to assume that these statistics you can get on solar are always just right, and for you to do something even crazier and believe the P90 is some kind of meaningful case, it's just a downside case with a whole bunch of judgment like you always did in your whole life. It's what a bank should do, and we can visualize the results, and it gives us a little bit of variation each year. And now this thing doesn't allow you okay, I don't know where I put it. It doesn't allow you to get the data itself. So you go to the PDF, and then you get the data, and then you select the data. Let's select it like this. You copy it. Let's go to a new spreadsheet this time. Control N. Go to a new spreadsheet. Alt E S. Unicode text. It puts it in a stupid single column. That's a single column. So what you can do is go to this page on the website. You go up to the top and you download the very first file, which is, it says it's a read PDF to Excel. You download that file right here. Put all the files here. And then you go and open this file, and it's kind of like our generic macros file, okay? And it says Shift Control A to operate. You press Shift Control and the letter A. And I totally understand people in the class who were saying, how in the hell am I supposed to remember that? You know, if you had a video and you can go through it slowly and see it, then you can fast forward it and whatever. You know what I'm talking about, I hope. And then you press the green button a couple of times, and it will arrange the data for you. Now, I've worked on this. I stopped working on this about 5 years ago, I think. Alt ES. Oops. Why didn't that work? I just want to, oh, I got to copy it, I guess, instead of cutting it. Alt ESE, right? Okay, and let's just delete this crap up here. And this is the year, obviously. Shift space bar, Control minus, put a total over here. And after we put a total, we So let's just get the sum here, and then we're back to where I was just showing it to you. Oh, no, don't worry. Don't worry. And then we get this. Now, there's one principle that this little thing will show as an example, and make sure that our formulas are still on calculation, okay? And I put sum, and I meant to put average. You need the average, and you're going to make an assumption that these are normal distribution, STDEV, okay? And then we can put our p-value, and if it's P90, we'll put the complement of it. That means I'll put 10%, or we can put 1% for P99 or whatever. P50 is just the average, so you're not going to do that. Okay, and then we compute the average of it. Okay, and by the way, yeah, okay. I'm just going to talk through this one. To make a graph, kind of a nice graph of these p values, you want a normal distribution and show it and put some stuff. I'll show you that. What the heck? I'm contradicting myself a lot. If you go to energy analysis, and then, because this is kind of like this is more like a class, and if I go a little longer, I don't really care. I'm not going to put myself under more stress by saying, oh, this got to. So if you want to make a little graph like this, you can find a file and put your standard deviation and get all of that done. Okay, I'll go back to our course now. Okay, so that's the kind of how the website works. And then you put STDEV, and if you don't know what to do, I always put S, because just about everything is a sample. There's no such thing. You could get philosophic about it. I think there's no such thing as a population. And then we can, if we want, we can look at the STDEV as a percent of the average. Now these are pretty big, okay? But if you go, and we almost should shift control P, because I've got, look at how much less the total is. Now, there is a man named, Harry Markowitz. I think he won the Nobel Prize. I don't think he got a PhD. I'm not sure. I don't think he was a professor at University of Chicago or anything like that. I don't think so. I do a Wikipedia on him. Taleb said he was doctor. I'm not sure he was. Okay. He said, well, if you start combining things with different standard deviations and they're independent of one another, the total always has a lower standard deviation than the individual parts. Okay, and down here, let's do P90 divided by P50. Now, I don't know if I'm going to, I should do it the other way. P90, which is just a downside case. Is that too complicated to say that that's just a 10% downside case? You could say there's a 90% chance of being better than this. That's if you were trying to explain it to your mother, or 1 out of 10 years, 9 years, 1 out of 10 years, it's going to be this level or worse. Is that okay? I hope. And we want to, as a bank, their big responsibility is to come up with a downside case. Okay? And so if we put the downside, there's just a nice formula, and I didn't have a chance, and I'm not having a chance right now to work through it all. You can look at that file I just opened and actually work through it. But if you put norm inverse, okay, and then you put this probability in, and I'll just put it like this to keep it on B, and then you put the average, and then you put the standard deviation, and we could have, if we had a percent, we could have done this. It will give you a number, okay? And there we go. Oh, shit. Oh, I see. I have that stupid other one open. Oh, I've got it. Just a minute. You know what I got to do is I don't need this one open. I did I did something very bad. I replicated some of these shortcuts. I've got to redo the names of the shortcuts and use alternate Q or something instead of Shift Control Q. Okay? This is this one. Oops. What's going on? Oh no. Oh. Okay, screw that. It just opened it. Oh no, now I'm really. Okay. Oh gosh, now that lady from that place is going to give me all kind of crap. So if I take this 72 divided by 84, how about Shift Control P on that at least? And just screwed everything up. Okay, it says that the downside case is 84% of the base case. But then when we go and we combine a bunch of independent things together on an annual basis, and really you might be paying debt off on a semi-annual basis, so you could do this on, maybe you could do this on 2, you can see that there's only a 3%, the downside case is only whatever 2.5% below the base case, and you can do the same thing. I'll just do it like this, Shift Control 1, and we can put norm inverse. Okay, and I used to go kind of crazy and think, oh, this is so complicated. And you take the average and you take the standard deviation, and I used to be so proud of this. I probably repeat myself way too much about it. Okay, and so we could put the P99 divided by the P50. And remember, that's just a downside case. You're just supposed to Control D and something like this, okay? You're just supposed to understand that it's a downside case. You don't have to be, you don't even have to remember some statistic class you took while you were, you hated or something like that. You just have to use norm inverse and get the standard deviation and not be afraid of this kind of stuff and understand that you can do this. Now, if you would do a trick here, if these distributions and the variations month by month were completely independent of one another, what you could do is take this standard deviation and then square it. Okay, there's something called mean squared error, which I can't remember in statistics. I don't think they went through it. Okay, and then what you do is you sum this. Does alternate equal works? Okay, alternate equal works. And then once you sum it, you take the square root, 0.5. And then I get 35. And look at this. Oh my gosh, look at how close this 35 is to this, suggesting that the deviations month by month are independent. It's almost like you could go backwards and test for independence, with something like this, but that's just what I thought of now. Okay, and that's the idea. And now, guess what I'm going to do? I'm going to close this and not save it. And if anybody says, oh, no, you didn't save it, well, I put the same thing here and I completed it. And the other thing to understand about standard deviations, and I don't know if I hope you can see this kind of stuff. This is if you make the effort to ask me about my resource library that I give away, you can find some examples of this. And here's what they do. This is in wind. They give you the variability, and they call it energy uncertainty. Why in the hell they can't call it standard deviation? I don't know. I really don't know. This is just the standard deviation, and the standard deviation expressed as a percentage. Now, if you would add these up, it wouldn't work. It's just like our other thing. They are assuming each thing is independent of one another, and then they have the energy variability separate from some of these other things, and these other things really amount to errors in modeling. Okay, and perhaps I didn't get this across clearly enough. I think of Victoria's Secret not as a bankruptcy, and I think that this went out of fashion. That whatever they made their models too thin or whatever in the heck they did. Or I think of obsolescence like Kodak. And when you have those kind of risks, they go down and they're gone, period. And modeling risk is like that. There's no mean reversion. Once you get it wrong, you're finished. But this kind of variability, when we just cycle up from year to year, is totally different risk. Couldn't be more different. And I go kind of nuts in my book that I even just made a video. The fundamental difference in risks, understanding what's mean reverting, and I'll accept that. And that's why we have this thing called 10-year and 20-year, because that's kind of interesting that say that's an acceptable risk because it's just a cycle. It's just a weather cycle. Well, okay, there's global warming. We all know that, except my sister-in-law says there's no such thing. God, okay. They're cycles in weather. Still, the winter is colder than the summer in where I am and all that. Okay. So understanding the difference in risk is a big deal, and maybe I'm babbling too much in the middle of a modeling thing. Now, if we wanted to do this, there's a trick where you say that I forgot what the 1.95 is 2 standard deviations or something else. I have to do it quickly. If you get a table of what's P99 and P95 and all that, what I do is I just say, okay, let's put a mean, and let's put a standard deviation in here, and let's put a p level, and let's take this one. We have a P95 is 280, okay, and the P50 is 340. I have to lean over here. I can't really see it. It's too small. 340.3 standard deviation. I don't know. I'm going to put 30. And the P level is 0.9, 0.05. It's a complement, and the target then is 280. I can even take it from over here, okay? And then I say, well, let's take this, the difference. Let's take the computed here and just compute this and put norm inverse NORM INV, and take our P level, take our P50, and take our P90, and then you get, what did I do? Oops. This was supposed to be the standard deviation, sorry. And we take the difference between what we computed and what we calculated, and notice I just threw a number in here, and you just go to the data, and after you go to the data, you go to what if analysis and goal seek, and you set the difference to a value of 0 by changing the standard deviation, okay? Goal seek's just wonderful. It really is, I think. Yeah, I try to do it by hand and all that, and it gets kind of painful. And then if we take this 36 and we take this number and we want to see if it really works, we put a P level of 10%. And I hope I can copy this over, and that gives me 239.9. Exactly right. How about if I put 0.25 for the 75? Then it gives me 315. So if I want the P99, I just point 0.01, and we get that. That's that's how we do it. Now in this case, I put just to illustrate how all of these P values work, I said, okay, let's do a little mean squared error, and let's look at kind of the standard deviations, which they don't show you, of course, stupid in these reports. Okay, let's look at the standard deviation for this one, and this one. And all we do, this is from a wind study. If it's a 1 year, we take we always square it. Okay, and then we just copy this all the way down, and I stop here at the 1 year. And you notice the biggest variability is the 1 year. And if you want to do the 10 year, you go over here and square it. Oops, yeah, square it again. But this time, go all the way down and don't take this one. So you can see that this has the cyclical variability in it. And I should have done some kind of F4 on this, but I didn't. Okay, so let's go all the way down to the 20 year. And this, how you get averages over 20 years, you'd have to get 20 year, 20 year, 20 year somehow. Really, a whole lot of data. And then you sum it. That's the sum of the squares. I should have done alternate equal. Okay, at least there I can press Shift Control R, and then you take the square root of this. Okay, and I've done this fairly quickly, and you can go and practice it. That's why I gave you the file, and that 36.22 is where close enough to this one. Okay, and you can see that a 1 year P90 has a whole lot of cyclical variability, plus all these other things that God knows how they get these things. Who knows? It's just a downside case. Somebody's making a lot of judgment. They can claim they have some fantastic data, and you can believe all that shit if you want, but it's just crap. Okay? And that's how you do it. Now, if we looked at a solar one, I didn't take a solar one, this PV cyst, they always put, the biggest thing they put in there is the uncertainty around degradation. What a lot of crap. We're talking about a P50 versus a P90, a starting point. We're not talking about over time. You can see just what rubbish there is in this stuff. Okay, enough of that. So that's our starting point. Finally, back to the model. And so we have a P50 case. If I want a P90 case, I put norm inverse, and I take the probability. This is the 1 minus the probability. And then I say, well, what's the mean? Well, that's the P50. And then I put the standard deviation as this multiplied by this one. Okay, and whoops, I pressed F5 instead of F4. And then we can get our P90s and P99s. And that's kind of the whole point of this one. All right, let's press Control-Alt-C. I can relax for a second. Do you want to delete the format conditions? Let's put no for once. It does the reset. You've got to make absolutely sure if you had a conditional formatting that you would unclick that one, and then you can color the sheet. I hope I put them in B, and let's put a little beautiful little black thing on the top with 4 things. Okay, and then I need to put apply. Can't remember how to do this. Apply top color. You can see how to make these things in. You go into the generic macros and you can see, oh, how did you make that little? Well, it's called this same shit. Oh, God. This is the one I didn't fix from before. Oh, I am so sorry. Oh, how could I have not done that before? Oh, no. And then I've got to redo it. And then if I have to redo it, well, I'm going to redo it now. Okay. Well, I did that on purpose. I wanted you to see the code and not get intimidated by the code. And that took a little bit long to do. Okay, and I think we did about 4 of them, right? And okay, I hope this is going to work now. And I just changed it around, and I'm trying to make it more efficient and all the rest. Okay, and then we have little headings, and you can make the headings longer or shorter, and hopefully you don't waste a lot of time with all your coloring, which some people think to do. I do get obsessed with coloring. I told you that once I went to Switzerland when my mother grew up and I used to go. I loved it. And the man asked, well, what's your passion in life? And I said, it's coloring spreadsheets. And the real sad part was, it's true. Sorry, bigger passion is solving circular references. Okay. Now, there. Okay. Now again, we have the same kind of thing. And what did I do here for the S curves? I put everything in 100% upfront in order to reconcile to a levelized cost analysis. And let me just see for a minute how we're doing. Okay, I'm already on 40 minutes. I'm going to split this video into two parts. I get so nervous when I imagine people sitting there listening to me. The class is such a torture, and I can't imagine anybody watching a video for this long. So there are just a couple of principles. Now, last video we went through the timelines. Okay, so this is just got the monthly timeline in it right now. And in the monthly timeline, we use our operations flag. And I am not going to waste time coloring the sheet. And then here's what I suggest. And I learned it by working on, and I'm going to be a little inconsistent, but foolish consistency is the hobgoblin of a petty mind. But the idea, the general notion is, if you're using kilowatt hours, use it all the time. Don't start switching between kilowatt hours, megawatt hours, thousands of euros, euros. Put it all in euros. Well, I'll probably put most of it in megawatt. I'm going to be a little bit inconsistent here, but at least I'm going to do it both. And at least I made the point. Okay? So if I'm being a hypocrite, I'm being a hypocrite. So we're putting our capacity in, and we're oops. Oh God, shit. Okay, I didn't turn it off. Oh well. I'm gonna have to go edit the video then. Okay, I'm going to. This was just because I had the zero degradation scenario. And if we would change this, it's kind of a good thing to look at. We go through the degradation. So we start with all of our stuff related to operations, and then we put all of our PPA stuff in, and the degradation is number 3. And if I am on scenario 2, if I press 1, then we have the base degradation, and then we have it appropriately. Okay. I'm gonna go do that, and then we can get our monthly degradation, just like we do other things that are going to sum up to 1. And whenever you do that, you better put 1 divided by 12 or months minus 1. You notice I'm too lazy to find my little thing. And then we make an index, just like an inflation index. And you would, in this case, I suppose I kind of cheated, but I didn't. The degradation index should have been this times 1 minus this number and multiplied by the operation switch. We don't start degrading until we're born. I'm degrading a lot, like I always say. I'm way over there. Okay, and then we can multiply the generation by the degradation. Then I put the lookup on the months, which I think I did last time. And then I put some inflation in. Now, I did the inflation in the last video, so I thought I don't have to really do it again. And I put a rate in euro per megawatt hour, not per kilowatt hour. So that's where I was completely inconsistent. But we can take our, I put this in megawatt hours, okay, and we can take our seasonal generation that I kind of kept flat anyway, okay, and then just multiply the seasonal generation by the inflated price. And right now I don't have any inflation, and that's going to be all related to the very next video on reconciling all this to the levelized cost of electricity. And then I didn't put all these little factors in. I just kept the O&M really, really simple. And I said, okay, let's just take our revenues minus our expenses. So I didn't put all the expenses in. And if somebody complains, oh no, you didn't type how many pencils you have, or oh gosh, you didn't put how many employees you need. Okay, we just put they're basically fixed cost. You have somebody watching the fence, and then you've got a CEO, I suppose, who's got to look and say, how much is the sun shining today? And okay, let's go home. That's what you have to do. And you have to monitor a little bit. And then I put all the CapEx in one period this time. I did the S curve in the last one. And if this lady says, oh, you didn't talk enough about the S curve because you put that on the outline, well, tough crap. It's not that complicated. And then I guess we'll take our pre-tax cash flow, which is the EBIT minus the CapEx. Okay, and then we get our IRRs that I talked about last time. And in the next video, we're going to talk about getting a target PPA rate to make the IRR equal the target. But right now, it's getting late. I've got a plane to catch tomorrow, and I'm going to stop and make the second part of this video a little bit later, but I'm going to keep going. I'm not going to stop. Okay.